Finally getting back to this project, the finishing up of the video anyway. The transmission's back from rebuild. I got it back a little bit quicker than I thought I would. Had a 90-day turnaround time on it, but I got it back in about 60 days. Anyway, the transmission's now back installed, as you can see here, and the line's connected, the linkage has been connected, I even fit a dust cover onto it to protect, keep debris out of there. And now we can continue on and finish up this video. Now I'm going to go over a little bit of the shifting linkage that I used. I used the Low-Car kit, and you'll see here's the view of the top of it, and it's got a nice pivot point that it comes with that connects right up to the linkage coming off the column. And then I've created bends in it that you can kind of see here to go down to the transmission. And then there is the bracket on the side of the transmission that gives you all the adjustment for getting the correct amount of throw to use with this column. And the column I've used is the Classic Performance Aftermarket column. It gives me the park, reverse, neutral, overdrive, drive, low 2 and low 1. But you can actually get that bezel for the stock steering column as well. The critical point in this is to adjust it so with that sliding mount on the side of the transmission so that you get the same amount of throw between low 1 and park on here as you have on the transmission. And it's trial and error, but once you've set it up, the critical thing to do is make sure that you have park, reverse, and neutral in the same positions as they were on in here. Those are the three critical ones. The rest of the throw will be in the lower gears. And that's something that was kind of a trial and error thing for me, and then it just made sense. Well, those would be the same whether it was a Turbo 350 with only the 2 or the 3 speeds forward, or the 700R4. Your park, reverse, and neutral will be in the same position to make your neutral safety switch and your reverse lights work correctly. Decided it was about time I finished up this video and shown how I hooked up my TV cable to the carburetor. I have a Quadrajet, the stock for this 1972 350, and you can see on the bottom down there that I've got the TV cable connected, same place, almost the same place that a Turbo Hydromatic 350 would connect to, but they're on this particular carburetor, there's 2 holes on that bottom adjustment, and I'm going to tell you how I determined that I was going to use that one by illustrating it on my 56 Chevy. The 56 Chevy has the 700R4 in it as well, but it's got fuel injection, and the fuel injection linkage was based on Holley throttle linkage, and they make an adapter. And that adapter is right here on the side, right there. That's where the throttle connects. That's where the TV cable connects. And you can see the angle of that. Well, I measured that out from the center of the pivot up and over, and from the center of the pivot down and over to those. And I determined that on my Quadrajet, there were 2 holes on the bottom of this linkage. I'll see if I can get it removed with one hand. You can see that there were two holes. The front one was being used for the kickdown cable from the from the 350, the turbo hydromatic 350, but there was another hole back here. So I compared from the center of the pivot of this throttle to the mounting of the throttle cable and to the mounting into this hole, and found that they were within a degree or so of that specialty bracket that was made. So I decided to use that for the 700R4 kickdown or TV cable on this Quadrajet, and it has worked out extremely well. I'm going to try to illustrate how I adjusted this cable, and this is all opinion, by the way. We want to make sure that you understand this is opinion of how to adjust that. If you're really concerned about exact adjustment, I suggest you see the transmission person you respect the most. But the two different transmission people that I've worked with on this and on my 56 Chevy when I set it up were confident that the way I set it up would work just fine. There can be some fine adjustment using pressure readings and hooking up pressure gauges to the transmission. But for my casual driving, I'm not racing, I'm not doing anything but just driving this. I'm going to use my method. So let me see if I can describe that. The way that it was explained to me how to adjust this, and it makes it much easier since I have the low car throttle cable linkage here because I have adjustment down here. Also have the adjustment on the end of the cable outside of the bracket. But the way that I was told to set it up by the person that sold me my first 700R4 in the 56 was to once you get that angle correct for the offset of the pivot, which, like I say, I've compared it to the offset on the factory, or that aftermarket bracket made for a Holley type throttle linkage. They do not make one for a Quadrajet. So, but anyway, the way that it was explained to me how to set these up like I say, this is all opinion, is that you go to full throttle and then you have a 1/16 of an inch of play, about a 1/16 of an inch of play still in the end of your cable outside of here, so that it's not bottoming out on that valve inside the 700R4. And that the adjustment can be made on this with the low car setup just by loosening the nuts here. You get your approximate setting for your cable out the end of this, and then full throttle, about a 1/16 of an inch of play off the end of that. Like I say, this is opinion. I'm not stating this as fact, so don't quote me as this being the right way to do it. The right way to do it would probably be to go to a transmission expert, have them hook up pressure valves or pressure gauges to the transmission, put it under ideal running conditions on a dyno probably, but that's out of my price range. I have not blown up my 700R4 in my 56 Chevy, and it has over 6,000 miles on it and still runs, great. Okay, now a second thing is that the transmission builder that built this transmission said that you can also use the adjustment on here to create higher pressure earlier in your acceleration to create a firmer shift. And I'm not desirable of that firmer shift. I want this to be an everyday driver. And it does fine. It shifts. It feels great when I'm under load, or if I'm just casually driving. So I'm really happy with the way this one turned out, and I'm very happy that I was able to find the correct angle, or that this carburetor linkage on this Quadrajet has approximately the same angle as that aftermarket bracket that I have on the 56 on that fuel injection on there. So I'm happy with the way it's working, and I guess I'll follow up later if I burn up a transmission, but so far so good. And my transmission builder on this one said that the way I've set it up should work fine. It's a fine tuning that I would need to consult, maybe have somebody check pressures and things like that at shift points, but That's out of my price range, and I feel confident that I'm not going to be burning up my transmission. Now remember, all of this is opinion, so don't take my word for it that this is the way that it has to go. I've read lots of opinions on YouTube, and there are many. So we'll move on from there. I've set up a small demonstration here of my solution for the lockup mechanism for the torque converter. I've done this on my 56 Chevy, and I've liked it so far. Like I say, this is my current solution, but there may be something better out there. It's just all personal preference, but this is my current solution. I've made this small little circuit here. It's just 2 relays because I needed a way to latch the relay and to release it for engaging the torque converter. And I will provide the diagram of how I did that. But I'm using a small momentary contact switch, and I'm using, this is just for demonstration purposes. I'll have it so I can release the torque converter on, if I hit the brakes, it will disengage the torque converter lockup. And I've also set up a vacuum switch that will disengage the torque converter lockup if you accelerate hard in a normal circumstance. If you're on the highway and you're cruising and you want to have it disengage when you give it acceleration to go past somebody or something like that, this will do it. And so I've got the vacuum pump here to simulate the vacuum off of the manifold. I've got a light bulb here to simulate the torque converter. When the torque converter is locked, the light will come on. This is just a simulation. And I've got this momentary contact switch with a lighted ring. So the first thing I'm going to do is pump down or pull down the vacuum to simulate the operating vacuum of the engine, which is about 18, somewhere around 18, I guess they call it, inches of vacuum. And so I'm up to cruising speed. I push the button, lock up the torque converter. So that's showing that the torque converter is locked. The red ring will be on the dash. I'll have this located on the dash so you can see that it's locked up. So I come up on an emergency situation or just a normal slowing down situation where I have to hit the brakes, and the brakes will deactivate the lockup in the torque converter. And then the next situation, say the torque converter is locked and you are in traffic and you want to have it disengage when you accelerate to go, to like pass somebody or something like that, and you want it to kick down normally. I'm going to pull the vacuum out of this, and about 8 inches of vacuum, the vacuum switch will release, and it'll release the torque converter as well. And so then you go back up to cruising speed with no acceleration, and you're back up to normal operating vacuum, then you can re-engage your torque converter lockup for cruising again. Like I say, very simple latching relay circuit with 2 relays. One of them is just the latching portion, and I'm either disrupting by activating the release through the second relay using the brake switch, or I'm releasing by disconnecting the ground through the vacuum switch when it drops vacuum when you accelerate. And that's my solution. I will also put a graphic in of this little circuit and the way that I've set it up, and I'll be showing a little bit of the installation when I start installing it into the truck. You can see here that's where that was my temporary switch for the torque converter lockup, just for testing. The red wire I'll still use because that goes down to the torque converter, but I'm going to be installing the button for it in one of 2 locations. There's a spot right behind here. There is a spot right behind here that are holes in the metal dash behind this that were either used for, I believe, manual choke or maybe throttle. So I'm not sure which one I'm going to use yet. I've put the one here on one other truck, and it's okay there. I think I'd prefer to use this one over here just because it's closer to where you're shifting, but there is duct work behind there that may get in the way. So we will see on that. So the first thing I need to do is figure out a place to mount the vacuum switch. The vacuum switch, I've determined, would be better to have it out on the engine near where the vacuum hooked up to. Instead of running a vacuum line inside, then I'll just run the wires inside. So I've made this little bracket to put onto the vacuum switch, and I'm going to mount it on the bracket that holds the spark plug wires separator, which is right next to the distributor. I decided to paint it orange so that it kind of matches all the other accessories under there, and then mount it in there. It looks pretty good. And then just run the rubber vacuum hose over to it, and that completes the installation of there. And I've routed the wires up along the firewall to bring them into one of the holes in the dash. With the gauge cluster out of the way, I can bring all the wires up through the opening there that I need from the brake switch down below, the vacuum switch outside, positive and ground, and then the positive that's going to go back down to the torque converter itself for the lockup solenoid. Then I've got my little circuit here, and attaching all the wires to it. I marked them all, got them all connected to it, and then I put heat shrink around the whole thing just to keep it isolated and make sure nothing shorts out, and some double stick tape, and then taped it, stuck it right down to the top of the steering column where there was a blank space down there. If you look over to the right side of the opening in the dash, you'll see where I've routed the momentary contact switch wires to. That's where I've decided to put the switch for the lockup mechanism. And now with the push button in place and the dash cluster back in, let's take this for a drive and see how it works. Okay, we're up to 55 miles an hour, and I'm going to engage the converter lock now. Now we just dropped our 200 RPMs for the converter lock being engaged. So if I wanted to give it some acceleration, I can ease into the acceleration and, gaining speed, no problem whatsoever. But if I need to accelerate a little quicker, I want to have it disengage, and it does by just pushing down on it further, and the vacuum switch will disengage it for me. And then if I want to re-engage it, I just push it down again and it re-engages. And again, if I want to accelerate a little bit more rapid, it unlocks the torque converter and allows it to shift down. Now the other way that this will disengage is by applying brakes. So I'm coming up on the exit on the freeway now, and I'll be applying brakes when I start getting onto the freeway exit. So now that I've applied brakes, you can see that it disengaged the torque converter as well. Well, that's the end of my video. I hope you found it useful and maybe entertaining in some way. I doubt that, but anyway, it's working great. Been driving it 2-3 times a week since then, as weather permits, and it just runs great and drives great. Really enjoying it now. So thanks a lot for watching, and take care.